All right, welcome back to our unit on chemistry and measurement. Our topic today is units and unit conversions. Okay, so it's lesson 3 of 4. Your objectives are as follows. You will understand the relationship that exists between mass and volume. Okay, you will learn which units we use to measure mass, volume, and length. You will learn what the metric system is and the common prefixes used in measurement. And finally, okay, you will learn how to convert between two units of temperature, degrees Celsius and Kelvin. Okay, if you need more time to write your unit and topic on your notes, go ahead and pause this. I'm going to move to the Quickwrite. Okay, for your Quickwrite, remember your Quickwrite is just to get you thinking about today's topic. There's no wrong or right answer. It's simply what you think. All right, so in 1 to 2 sentences, answer one of the questions below. What are some units of measurement you're familiar with? Okay. In football, the field is measured in yards. Is the yard part of the metric system or the English system? Analyze these two gold blocks, A and B. Okay. Which one do you think has more mass? Okay. Which one do you think has greater volume? All right. Go ahead and pause this if you need more time to complete your Quickwrite. I'm going to move on. Okay, so the mass and volume relationship. Mass is how much stuff or matter an object is made of. Okay, think of mass as how many atoms or molecules make up an object. Okay, for example, consider these two gold blocks, blocks A and B. Okay, both of which are naturally made up of gold atoms. Okay, but which block has more mass, block A or block B? Okay, well, because block B contains more atoms or stuff, it therefore has a greater mass. Okay, and we could verify this when we put them on a scale. Okay, notice block B has a greater mass. It weighs 90 grams, block A 50 grams. Okay, so the block with more mass, block B here, contains more atoms and will therefore consequently or naturally weigh more as a result of having more mass. Okay, so notice here, mass is measured in grams. All right, so if an object has mass, though, it takes up space and therefore it must have volume. Okay, volume measures how much space an object takes up. It is measured in either milliliters or centimeters cubed in this class. Okay, so once again, consider our two gold blocks here, blocks A and B. Okay, which block has more volume? Okay, in other words, which block takes up more space? Well, because block B has more mass, it should have a greater volume. Okay, so just by looking at block B, it looks like it should take up more space. But we could also investigate this further by submerging both blocks in equal amounts of water. Okay, and notice, block B takes up more space. Therefore, it displaced more water. Okay, therefore, block B has a greater volume. Okay, so for your notes, what is the relationship between mass and volume? Question on the left-hand side, the answer down here below on the right-hand side of your notes. Okay, go ahead and pause this while you write. I'm going to move on. Okay, so the metric system. In science, especially chemistry, we use the metric system. Okay, the metric system is a measurement system based on multiples or powers of 10. Okay, consider this meter stick here, which we use to measure length. Okay, 1 meter contains 10 decimeters. So in this 1 meter, we have 10 decimeters. Okay, or 1 meter is equal to 10 decimeters here. Okay, 1 meter also contains even smaller 100 centimeters. Okay, so in 1 meter we have 100 centimeters. Okay, and 1 meter also contains 1,000 even smaller millimeters. Okay, in this ruler. Okay, so 1 meter has 1,000 millimeters. Okay, so notice each unit becomes 10 times smaller with a different prefix as we got down to our very, very small units here. Milli, 10 times smaller. Okay, so deci was 1/10 the size of a meter, a centimeter was 1/100th the size of a meter, and a millimeter was 1/1000th of a meter. Notice we simply put a prefix in front of meter as we got smaller. Okay, our base unit here is the meter. All right, so the same is true if units become larger. 10 meters, we put a prefix in front of it and we get a decameter, 10 meters. A hectometer has 100 meters. A kilometer has 1,000 meters in it. Okay? So each prefix here tells us how large, okay, or in this case, small a unit is. So millimeters we would use to measure very small things. A kilometer we would use to measure very large things. Okay, distances that are very large. Okay. Well, the metric system uses, okay, some base units here. We use the meter to measure length, the gram to measure mass, and the liter to measure volume. Okay, these are the units, the base units of the metric system. Okay, and then we simply place prefixes in front of them to indicate the size and scale of each unit, whether it's 10 times, 100 times, or 1,000 times smaller, or 10 times, 100 times, or 1,000 times bigger. Okay? So remember, if it has milli in front of it, okay, you're probably measuring something that's very small. If it has kilo in front of it, you're probably measuring something that's much larger. Okay? So what is the metric system? Question on the left-hand side, answer down below here, okay, on the right-hand side of your notes. Make sure you write this table down here. Okay, go ahead and pause this while you write. I'm going to move on. All right, so unit conversions in dimensional analysis. Have you ever calculated your height in inches or your age in minutes? If so, you've performed something called unit conversions. Okay, a unit conversion is a method of changing a measurement from one unit to another. Okay, unit conversions are done using dimensional analysis. Okay, in chemistry, many of the calculations will involve unit conversions and dimensional analysis. Okay, I'll tell you right now. Okay, the better you are at dimensional analysis, the easier life will be in chemistry down the road. Okay, so dimensional analysis is a mathematical system using conversion factors to move from one unit of measurement to a different unit of measurement. Okay, so there are steps we use when solving dimensional analysis problems. Okay, so let's say you have a guitar here that's 1 meter in length. Okay, and you want to know the guitar's length in millimeters here. Okay, so it's 1 meter in length. How many millimeters long is this guitar? So through a series of steps, we can solve this problem. Okay, so step 1, start with what the problem gives you. All right, we know the guitar is 1 meter in length here. Okay, step 2, what are the conversion factors? We know that 1 meter has 1,000 little millimeters in it. Okay, that is our conversion factor. Step 3, set up the calculations so the units cancel. We have meter here. We're going to want meters down here so we can cancel them. 1 meter goes here. Okay, and we know 1 meter is equal to 1,000 millimeters. Okay, we can cancel our units here. Whatever is not canceled or crossed off, okay, should be what the question is asking for. And in this case, millimeters. So we're good. So millimeters, the units that the question is always asking for, should go in this top right-hand section. Always write your units when doing these problems. Very important. Units are more important than numbers when doing dimensional analysis problems. Okay, so step 4, solve the problem. Okay, at this point, it's a simple multiplication and division problem. 1 times 1,000 divided by 1. Okay, think of this as a big division line. 1 times 1,000 divided by 1 gives us 1,000 millimeters. Okay, that was a particularly easy problem. Let's move on to one that's a bit more challenging here. All right, so a year is 365 days long. How many minutes are in a year? Okay, so through a series of steps, we can solve this problem. All right, step 1, same steps. Here we go. Start with what the problem gives you. Well, we know a year is 365 days long. Step 2, what are the conversion factors? Well, one day has 24 hours in it, and 1 hour, okay, has 60 minutes in it. Step 3, set up the calculations so that the unit cancel. Okay, so we have days here. We're going to have days down here. So let's put 1 day there, which we know has 24 hours in it. Now notice something here. We have hours here. We're going to want hours down here, so our units cancel. So let's go ahead and put 1 hour down there, which we know has 60 minutes in it. And our units all cancel here. Our days cancel. Our units of hours cancel. Okay, whatever isn't canceled out should be what the question is asking for. In this case, minutes, which is correct. How many minutes are in a year? Okay. And step 4, solve the problem. So 365 times 24 times 60, all divided by, think of this as a big division line, divided by 1 times 1 gives us 525,600 minutes in a year. Okay? So, for your notes, what is dimensional analysis? Question on the left-hand side, answer on the right-hand side. Okay, make sure you write the 4 steps here. You will be using these steps later. Okay, go ahead and pause this while you write. I'm going to move on. Okay, so practice. Write this question on the left-hand side of your notes. Do your calculations on the right-hand side of your notes here. Go ahead and pause this while you do this problem. Okay, when you're ready to check your work, hit play. Okay, so let's see how you did here. You walked 5 kilometers to school today. How many meters did you walk? Step 1, start with what the problem gives you. 5 kilometers is how far you walked to school today. Okay, step 2, what are the conversion factors? Well, you know, okay, that 1,000 meters are in 1 kilometer. Okay. Step 3, set up the calculations so the units cancel. Now we have kilometers here. We're going to want to have kilometers down there. So let's put our kilometers here. And 1 kilometer has 1,000 meters. Okay. And our units cancel. After that, it's a simple multiplication division problem, which brings us to step 4. Solve the problem. 5 times 1,000 divided by 1 tells you that you walked 5,000 meters to school today. Okay. All right. So the last thing we're going to talk about today is units of temperature. Okay. When measuring temperature, 2 units of temperature you will need to become familiar with is the Kelvin and degrees Celsius scale. Okay. Kelvin is the more scientific scale. Okay. So on the Celsius scale, water boils at 100 degrees Celsius. And on the Kelvin scale, water boils at 373 Kelvin. Okay. So as the temperature cools, water freezes on the Celsius scale at 0 degrees Celsius and at 273 Kelvin. Okay. And the lowest possible temperature in our universe, where all molecular motion stops, occurs at negative 273 degrees Celsius and 0 Kelvin. Notice 0 is the lowest possible temperature on the Kelvin scale. Okay. Well, today we're going to learn how to convert between these 2 scales. So to convert between the units of temperature, we will use the following equation. Degrees Celsius plus 273 equals, okay, Kelvin. So, for example, let's say we want to convert 100 degrees Celsius into, okay, Kelvin. So, substituting our values into the equation, we get 100 into degrees Celsius here. 100 degrees Celsius plus 273 equals 373 Kelvin. Okay. And notice we could verify this over here to the right, okay, by checking our thermometers. 100 degrees Celsius is equal to 373 Kelvin. Okay. So practice on your notes. Write the question on the left-hand side here. Okay. Go ahead and pause this while you do your calculations. When you're ready to check your work, okay, hit play. Okay, so let's go back here. Okay, convert 293 Kelvin into degrees Celsius. So plug on our 293 Kelvin, and we get, okay, 293 minus 273, okay, and we get 10 degrees Celsius, which makes sense. Because over here we have 10 degrees, and over here equates to 293 Kelvin. Okay, so summary, you can always write your own, okay, or you can do mine, okay. Explain the relationship of mass and volume in your own words. What do we use to measure mass, volume, and length? Okay. What do the following metric prefixes represent? Centi, milli, and kilo. Okay. If you're 60 inches tall, how many centimeters tall are you? Here's your conversion factor. Convert 310 Kelvin into degrees Celsius. Okay. Go ahead and pause this while you do your summary. We'll see you next time for day 4.